Hi guys, myself Prithvi and I'm your technical trainee and I'm gonna teach the Ansys software. The Ansys software are completely under the simulation like fluid dynamics, structural mechanics, electromagnetics, system and multiphysics. We'll be working on it. And let's talk about the Ansys software. The Ansys was invented by John Swanson, that is in 1970, and right now its company is based in Canonsburg, Pennsylvania. It develops and markets multi-physics engineering simulation software for product. And like we'll be talking about the fluid dynamics, electronic designs and other physics analysis will be done in the Ansys software. And right now we are using the version of Ansys 15.0, that is comes with the FEA simulation package, that's finite element analysis package. It is developed in Ansys in USA and the international quality standards it's ISO 9001 2000 and more than 450,000 customers prefer Ansys before manufacturing the products. I think more customers are using right now. At this current generation, the Ansys software is required for the industries before the manufacturing, so they can get the detailed view of the product, what they are manufacturing and everything. And objects of Ansys will be having CAD and CAE, that is computer aided designing, as well as computational fluid dynamics, as well as the introduction to simulation will be same, and we'll be having finite element analysis and finite element method. The concepts of Ansys. What is the main concept? Ansys is basically a software where when a body is created and the elements are into finite number and it will be in a mathematical model, as well as it will be under the boundary conditions where the finite elements can be defined easily and we can calculate the stress and strain and the deformation in the body. The Ansys works like 3 steps for the basic. It's pre-processor, FEA solver and post-processor. These are the sequence used in Ansys. Let's talk about the pre-processor. For an example, let's create a solid model. Okay, after creating a solid model like a cylinder, assume it as a cylinder, we'll have some boundary conditions like a cylinder in a boundary box. After that, giving the material properties like it's in the steel or in copper or any other material properties, and we'll mesh the file, and the mesh, like in the sense we'll mesh the solid body and we apply the loads in the north and the south direction, this for the cylinder, and we have some boundary conditions in between the solid model. This comes under the preprocessor. And the next is FAA solver. That is, we'll be working in the stiffness matrix, and these are completely under the mathematics where the software does it. We'll be finding the calculated stress and strain, and we'll find the displacement in the FEA solver. And the next comes the post processor. The post processor is completely like knowing about the results which have been defined by the solid body, the cylinder. The results you will be seeing in the post processor. The post processor results are in the form of table graph, contour plot, deformed shape, or in an animated view. These are the ways where the post processor works, where the analysis can be shown through the graph or any plot. And this is the Ansys user interface in the software, and this is the sketcher interface where you will be drawing the model and it will be extruding the model to the solid body and all the options available over here. We'll be talking about it later. And next comes the model design in Ansys. This is an example how a model looks in the Ansys user interface. where the mesh files are completely meshed to the cube and the material properties or everything has been applied. This is an example and overview of an solid body in an Ansys user interface. And this is the stress-strain relationship. I think everyone would be aware of the stress and strain. Let's make a glance. This is a graph of a stress and strain. Let's see what is stress and what is strain. Stress. Stress is defined as a force per unit area. Everyone gets stressed. The same thing. Common things apply over here. And what about the strain? Strain is defined as a change in length by its initial length. Here comes the applications of the Ansys. Ansys it's used in the aerospace, automotive industries, buildings, as well as in exporting goods in the cargo planes to calculate the weight of the loads which they are carrying, as well as the buildings, blocks, beams, how much weight can they withstand. And in the automotive comes the flow of air. These are the things, are the applications of the Ansys software. And here we come the PC requirements. These are the requirements to install a Ansys software to your PC. This is the requirements. So please check it out and please try to install the software and please work on it. And we'll be here to help with you. Okay, thank you so much.